So now in continuation, let's see some more questions based on surface area and volume. Question number 7. A semicircular sheet of diameter 28 centimeter is bent to form an open conical cup. Find the capacity of the cup. Use √3 is equal to 1.732. Right? So what is given here? What is the case given here? So let's first understand this. So there is a semicircular sheet, right? The sheet is semicircular. What does it mean? What is the shape of the sheet which is given? It is semicircular. So let's draw a semicircular figure here, right? Okay. Okay, so suppose this is a semicircle. Okay, this is a semicircular sheet. This is A, suppose this is B, and this is C, this is O, right? Now, the diameter of sheet is 28 centimeter. That means this AC is 28 centimeter. Getting that? So what is the radius of this semicircular sheet? 14 centimeter, right? This is 14, this is also 14. Right? Now this semicircular sheet is bent to form an open conical cup. So many times you have done this in while doing the hand, the crafts type of things, right? That if you have a semicircular sheet, you can easily form the cup, a conical cup from that sheet, right? So same thing we have done here, and this cup is a open cup, right? It is an open cup so that it can hold something, right? So now let's see how it looks. It will look like this. Okay, and since it is an open cup, it is open from its descent, right? Okay, so this semicircular sheet is bent and formed, this conical cup is formed. Now we have to find the capacity of the cup. Is it clear? So when you are folding this, when you are bending this sheet, right? What is this slant height? Which parameter of here will actually convert it into the slant height of this cup, of this conical cup? Just think and tell me that you are bending it, and suppose you are bending at this point, O, right? And this is O. Is that clear? Okay. So now O, and when you are bending, this A and C, right, will join together. A and C will be the same point, right? So this is A or C, right? They will be at the same point, and this middle point will be your B. Getting that? So this OB is what now? This is what is it actually? This is the radius, right? So the radius of the semicircular sheet will become the slant height of this conical cup. Getting that? Right? This becomes the slant height of this conical cup. Are you getting it? Yes, Anvi and Rudra. Right? Okay. Yes. And similarly here, this will be your 14 centimeters. So your slant height will be the radius of the semicircular sheet. That is 14 centimeters. Is that clear? Okay, that means for this cone, L is the radius of semicircular sheet. That is L is equals to 14 centimeter. Is that clear? Now, what we have to find? We have to find the capacity of the cup, right? One thing more which you have to notice here, that circumference of the base of the cone, this circumference. What is it now? Means which part of your semicircular sheet will become the circumference of the base of the cone? That is the length of the arc. This arc ABC will become this actually gets converted into this, right? Circumference of the base, that is equal to the length of the arc, right? Yes or no? So if circumference of a circle is 2 pi r, then circumference of this arc ABC of the semicircular sheet will be equal to pi into r, right? If it is 2 pi r, then it is pi into r. So the length of this arc will be equal to pi into r, right? Half of the circumference of a circle, right? So what it will be? The length of arc ABC, right? Which is actually equal to the circumference of the base of cone, right? This is equal to pi into r, right? Is that clear? So pi is 22 by 7 into r is 14. So this is 2, that is 44 centimeter. So length of arc ABC is 44 centimeter. That means circumference of the base of the cone, right, is 44 centimeter, right? And the radius of the cone, what is the radius of this cone? What is the radius of the cone? Suppose it is r centimeter, right? We have taken it, suppose r centimeter. This is r, right? So let radius of cone is r centimeter, right? Then the circumference of this cone, the base of the cone, which is a circle, is equal to 2 pi r, right? According to the formula, and this is equal to 44 centimeter, right? So equate it. 2 pi r is equal to 44. So r will be equal to 44 upon 2 pi. Getting that? Okay. So 44 upon 2 into 22 by 7, right? Okay. So this is 2. This is cancelled. So r is equal to 7 centimeter. So in this way, what we have got? We have got the radius of the base of the cone, right? Because base of the cone is a circle. It is a circular base having some radius. So using this, we can easily find out the radius of the cone, right? Now, since we understood, we have found out the radius of the cone, we can find the height of the cone, right? We can find out this height, this one, here to here. This is the height of the cone, h, right? Because we have to find the volume of the cone, then only we can easily find the capacity, right? So for that, we need to find h, height of the cone, right? So now, as we know that slant height L is equal to square root of r square plus h square. Getting it? Okay. Or in other words, you can say that L square is equal to r square plus h square. That means h square is equals to L square minus r square. Getting that? Okay. Or h is equal to square root of L square minus r square. Getting it? Now you can solve it. So h is equal to, now square root of L square. L is what? What is the slant height? Slant height is 14 centimeter, right? So put it here, 14 square minus r. R is 7 centimeter. Square of 7. Getting that? Okay. This is 196 and this is 49. Right? So 196 minus 49 is 147. Right? So h is equal to square root of 147. So as we know that 147 is not a square number. So first we will write its prime factorization here. So this is 7 into 7 into 3. Right? Now you can take 7 outside. So you can write it as 7 root 3. Right? 3 will remain inside the square root. So h is equal to 7 root 3 centimeter. And now you can put the value of root 3, which is given in the question. That is 1.732. Right? So put the value of root 3 here. This is equal to 7 into 1.732. That is h is equals to 12.12 centimeter. Right? So what we have found out? We have found out the height of the cone. Right? Now to find out the capacity of the cone, we have to find the volume of the conical cup. Right? So volume of the conical cup is equal to 1 by 3 pi r square h. Now we can put all the values here. 1 by 3, 22 by 7, r is 7, so it is 7 into 7 into h. H is 12.12, or you can also write in this form 7 root 3. 7 root 3. Right? Okay. Now you can cut this. 7 will cut. Right? 3 can cancel root 3. How many times? Root 3 times, right? Okay. So that is the same thing. Here you will get root 3. Okay. So this is 22 into 49 upon root 3, right? So what it will become? 22 into 49 is 1078 and root 3 is 1.732, right? So now divide this with root 3, that is 1.732, which is equal to 622.4 something centimeter cube. So this is the volume of the conical cup, right? So since we have got the volume, we have to find the capacity now, right? So the relation I told you, right? What is the relation? That 1 centimeter cube is equal to 1 ml. 1 centimeter cube is equal to 1 ml, right? Okay. So 1 centimeter cube is equal to 1 ml, right? So the volume of a cup, if it is 1 centimeter cube, then it can hold 1 ml liquid, right? So if it is 622 centimeter cube, if the volume is 622 centimeter cube, then what will be the capacity of that liquid, of that cup? That will be 622 ml, right? So how much liquid it can hold, or what is the capacity? Therefore, the capacity is 622 ml, right? So in this way, we have finded out the capacity of the conical cup, right? So what we have done here, we have used the relation between the capacity and the volume, right? So if there is any container having the volume of 1 centimeter cube, then it can hold 1 ml of liquid, right? So here the volume of the conical cup is 622.4, approximately 622, right? So if 1 centimeter cube is holding 1 ml, then 622 centimeter cube will hold 622 ml, milliliter. Is that clear? So this is the capacity of the conical cup. Is that clear? Yes. Now look at this question, question number 8. How many spherical bullets can be made out of a solid cube of lead whose edge measures 44 centimeter, each bullet being 4 centimeter in diameter? How many spherical bullets can be made out of a solid cube, right? So there is a solid cube made up of a metal, that is lead, okay? And edge of this cube is 44 centimeters. So as we know that cube having all edges equal, right? So there is a cube of lead which is solid, right? And its edge is 44 centimeter, right? Now, and this is made up of lead, right? Now, bullets have been made from this cube, right? After melting, we are making bullets, spherical bullets, right? And each bullet being 4 centimeter in diameter, right? So now we are making the bullets out of this, right? And each bullet is, suppose there's a spherical bullet, right? Okay. So this is a spherical bullet. And again, suppose this is solid. And each bullet is being 4 centimeter in diameter, right? So the diameter of this bullet is, suppose, 4 centimeter. This is one bullet, right? So now we have to find how many spherical bullets can be made from this lead, the cube, okay? The cube which is made up of lead, right? So when we are actually melting this and making the bullets, what will remain same? What will remain same? Length will not remain same, right? Okay, all dimensions will change, area will change. What will remain same? Only volume will remain same, right? So volume of the cube and the volume of the bullets will be same. Is that clear? Right? So since length of each edge of cube is 44 centimeter, right? Therefore, what is the volume of the cube? Volume of cube will be equal to, volume of cube is what? Side into side into side, right? So each side is 44 centimeter, right? So we have to multiply this 3 times, right? So volume will be 44 into 44 into 44 centimeter cube. So this is the volume of the cube. Now, what is the radius of the bullet? Since it is given that it's 4 centimeter in diameter. So since it is 4 centimeter diameter, so radius will be 4 by 2, that is 2 centimeter, right? So radius of each bullet is, that is R, is 2 centimeter, right? Now, what is the formula for finding the volume of the sphere? Volume of each spherical bullet, because it is of the shape of a sphere. So this is 4 by 3 pi r cube, centimeter cube, right? Okay. Now put the values here. So volume of spherical bullet and volume of the cube made up of lead will remain same, right? Yes or no? So what it is will come. First we will find it out. So this is 4 by 3 into 22 by 7 into 2 into 2 into 2. So this is the volume of one bullet, right? What we are finding? We are finding the volume of one bullet. So just find it out. So this will become 704 upon 21 centimeter cube. So this is the volume of one bullet, right? And now we have to find like how many bullets can be formed. So what you can do, because total volume will remain same, so number of bullets formed will be equal to volume of the cube in centimeter cube divided by volume of each bullet in centimeter cube, right? Why? We are dividing volume of the cube because volume of the cube and the volume of all the spherical bullet will remain same. Is that clear? So now put the values here. So now, what is the volume of the cube? Volume of the cube is 44 into 44 into 44, right? Upon volume of each bullet, which is 704 divided by 21. Centimeter cube will cut, right? So what you will get? 44 into 44 into 44 into 21 upon 704, right? So now you can check, they can be divisible, right? So 704 can be divided by 44 16 times, right? Then 4 11 times. This is 4, and again this 4, this 11 times is 44. So this is equal to 11 into 11 into 21, right? So now multiply. This is 2541, right? In this way, we have got the number of bullets formed is 2541 bullets from that cube made up of lead, right? So from that cube of lead, we are forming small spherical bullets, right? So what we have done, first we find out the volume of the cube, then volume of one spherical bullet, and now volume of the cube and the volume of all the bullets, total bullets will remain same. So volume of the cube divided by the volume of one bullet will give you the number of bullets which can be formed from that cube. Is that clear? Yes, sir. Now look at this question, question number 9. The internal and external diameters of a hollow spherical vessel are 20 centimeter and 28 centimeter respectively. Find the cost of painting the vessel all over at 35 paisa per centimeter square. Right? So what is the question? So there is a hemispherical vessel. As you can see here, I have drawn the figure, right? So this is hemispherical vessel, right? Hemispherical vessel. Okay, this is a hemisphere, right? Hemispherical vessel, which is hollow. As you can see, this is hollow in between, right? And now the diameters are given, the internal and external diameters are given here, right? That means if I draw here, right? So external and internal diameter, right? Okay, are given. That is 20 centimeter and 28 centimeter. So if these are the points, or we can simply find the radius from it. Okay, so rather than finding this, we can simply mark the radius, right? This is internal radius, and the here to here, this is external radius. Getting that? Right? So this is point O, OA, and this internal point is suppose B, right? Okay, so this is small r and this is capital R. Getting it? So write down outer radius of the vessel, right? This is suppose R, and this is half of the diameter, that is 28 by 2, that is 14 centimeter, right? Similarly, we can find the inner radius of the vessel, right? That is a small r, which is equal to, this is the inner diameter 20 by 2, that is 10 centimeters, right? So in this way, we have got r and small r and capital R, right? Now, what we have to find? We have to find the total area to be painted to find out the total cost, right? Total cost find out करने के लिए आपको पहले total area निकालना पड़ेगा, that what is the total area which is to be painted. Getting that? So what we will do, because since this is hollow, we have to find the area of the outer surface and area of the inner surface, both of them, right? So outer surface is which one? This is the outer surface, suppose this one, here to here, right? This one. And inner surface is this green one. This is the inner surface, right? So we have to find out the outer and inner surface of the hemispherical vessel. Getting that? Okay. So this is the inner surface and this one is outer surface. Getting it? This is the outer surface and we have to find the area of these two surfaces. Getting it? Okay, now we have to find out area of the inner surface. Area of the inner surface, the green one, right? What is the area of the inner surface? What is the area of the inner surface? What is the formula? Inner area of the inner surface means the curved surface area of the inner hemisphere. Getting it? Curved surface area of the inner hemisphere means curved surface area of inner hemisphere, right? So what is the formula of curved surface area of the hemisphere? This is 2 pi r square, right? The square units, 2 pi r square, right? Now put the values here. So here the radius which you will put will be the radius of the inner vessel, right? Getting that? So write down 2 into pi, right? 2 pi into r square, right? R square, that is 10. Small r is 10. 10 into 10 centimeter square. So this is equal to 200 pi centimeter square. I'm not changing it. I'm not putting the value of pi because I know later this will cut, right? That's why I'm not putting the value, right? Or we can solve it later, right? Now, similarly, we can find out the area of the outer surface of the vessel, which is the curved surface area of outer hemisphere, right? Again, formula is same, 2 pi r square, but this time the radius is the capital R, right? 2 pi capital R square. Now put the values. 2 pi into, now what is the value of capital R? It is 14 centimeter. So write out 14 into 14 centimeter square. Is it clear? So now you can solve this. So this is 392 pi centimeter square. So in this way, we have got the area of outer surface and area of the inner surface, right? Now, if you look at here, since this is a flat surface at the top, so this vessel is also having a ring at the top. Yes or no? Are you getting my point? And what is that ring? Paint to वहां भी करना है ना? We have to paint it that this portion. Getting it? This ring which you can see here, this is also need to be painted, right? Okay, so we have to find the area of this ring also, right? Ring, top ring you can say, right? So what will be the area of the top ring? Area of the ring at the top. What it is? It is like how to find out? This is the pi r square minus r square, right? Is it clear? Because it is, what is it? Pi r square, capital pi r square minus a small pi r square, right? Pi r, where r is capital and small, both of them, right? So if we subtract that, we can find out the ring of it. Getting it? Right. So now do it. So this will become pi 14 square minus 10 square, right? So this is equal to pi. Find out 14 square is, the square of 14 is, tell me first. 196 minus 100. So this is 96 pi. 96 pi centimeter square. So this is the area of the ring at the top. Now what is the total area to be painted? Total area
ring is this?
to be painted. Area. Total area to be painted will be the sum of all these areas, right? Okay, so now add them. Area of the inner surface, that is 200 pi centimeter square. Area of the outer surface, that is 392 pi centimeter square, right? And area of the ring, that is 96 pi centimeter square. So write them together. 392 pi plus 200 pi plus 96 pi centimeter square, right? So this is equal to 688 pi centimeter square. So this is the total area to be painted. Now, what is the cost of painting? This is the area which we have find. Now we have to find the cost. So cost of painting is given here at the rate of 35 paisa per centimeter square, right? So this is 35 paisa per centimeter square, means to paint per centimeter square. How much is the cost for painting? That is 35 paisa. So using this rate, we have to find the total cost of painting, right? So write down cost of painting the vessel This is equal to total area to be painted into the rate, right? So total area to be painted is 688 pi, and at what rate? Rate is 35 paisa. So we have to convert this paisa into rupees. So this is 35 by 100 per centimeter square, right? Area is also in is in centimeter square. So 688 pi centimeter square, and this is in rupees. So centimeter square will cut, and your answer will automatically in rupees, right? So now you need to solve this. So 688 pi into 35 upon 100, right? So you can cut this. So cut it. What it will become? 75 here, and this is 20, right? Okay. Yeah, we have to also put the value of pi, right? So let's write it down. So 688 into pi, 22 by 7 into 35 upon 20. 7 will cut. This is 35, we will already solve it. 7 will cut, right? So this is 10, and this is 11, right? Okay, so this will become 68.8, right? Into 11, right? That is 756.8. Okay, and this is in rupees, right? So total cost of painting will be cost of painting of the vessel, right, is rupees 756.8, or you can say 80 paisa. Is that clear? 756 rupees 80 paisa. This is the total cost of painting the vessel, and this is your answer. Yes, are you getting this? Please tell me.